So when is this topic here going to be covered in a typical OChem course? When is the interpretation of electron-pushing arrows covered in an OChem course? Well, it's usually covered pretty early in an OChem course, but it's also very often covered very briefly. That is, very often the class doesn't really spend very much time on how to interpret electron-pushing arrows. That might give you the wrong impression. That might make you think that this is not a very important topic. But actually, this is really a crucial topic for organic chemistry. The reason that oftentimes this topic is not covered at very great length is that, unfortunately, I think a lot of organic chemistry instructors think that it's already obvious how to interpret the electron-pushing arrows. After you've been working with electron-pushing arrows for a few years, they start to seem so obvious that it's hard to remember that to a beginning student, it's really not clear how to interpret these arrows. So don't get the wrong impression from your course. Even if your instructor didn't spend very much time on this topic of interpreting electron-pushing arrows, that's not because this is not important. In fact, this is really crucial to unlocking the whole rest of your organic chemistry class. If you cannot interpret electron-pushing arrows, it's going to be extremely difficult, almost impossible, to really do well in the rest of your OChem class. This is a key skill for the whole rest of your course. And the flip side of that is if you can start to easily interpret electron-pushing arrows, that's going to make the whole rest of your class so much easier, and also really so much more interesting and enjoyable, really. So this is really a crucial topic, and the reason I've decided to make a series of videos on it is, again, because both it's very crucial, and it's also, I think, a topic that is oftentimes really not covered thoroughly enough in class and in textbooks. I hope that many of the people that are watching these videos, I hope many of the students watching these videos are people who are at the beginning of their organic chemistry classes, because the best time to start learning this topic is near the beginning of an organic chemistry class, say during the first half of the first semester, because you're going to need the skill of interpreting electron-pushing arrows for the whole rest of the course. So I hope that many of you are trying to pick this topic up early. On the other hand, though, if you've already gotten deep into the first semester, or maybe even some of you are already in the middle of your second semester, if you haven't yet learned how to interpret electron-pushing arrows, well, it's never too late to go back and master this technique. So wherever you are in your OChem class, if this problem wasn't easy for you, if it's not easy for you to interpret electron-pushing arrows and get the charges right, try to make the time to master this topic. And I hope that this series of videos will help you with that. One more point that I want to make here is that in this series of videos, we are only going to cover how to interpret double-headed arrows. Notice that each of these arrows that I've drawn here has two heads. We're not going to cover single-headed arrows. Here would be an example of a single-headed arrow. Notice how there's only one fishhook, so to speak, on this arrow. So in this series of videos, we're going to cover double-headed arrows with two fishhooks, like this arrow on the right. We're not going to cover single-headed arrows, so we're not going to be covering this in this series of videos. A single-headed arrow is involved with radical mechanisms. Single-headed arrows indicate that you're working with radicals. That's an important topic. It's not quite as important, though, as double-headed arrows. So in this series of videos, I'm just going to cover the double-headed arrows, and maybe at some point I'll have a chance to go back and work on single-headed arrows. Single-headed arrows really are, in some ways, somewhat different from double-headed, so it's probably best not to cover them at the same time. So again, in this series of videos, we'll just be covering the double-headed arrows, so we won't be covering radical mechanisms. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos by going to my website. There's a link to the website in the info box. Here's the address of my website, www.freelance-teacher.com/videos.htm. That address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. I'll also mention that I offer tutoring via Skype, and you can find more information about that Skype tutoring service also at this website. And again, there's a link to that site in the info box. Thank you. This series of videos is intended for students who are finding this material to be difficult. So a couple consequences of that. So here's a couple consequences of that. Because I'm intending these videos for people who find the material difficult, I'm going to be trying to go very slowly through the material. I'm going to try to give a lot of examples, and I'm going to try to repeat myself a lot. And I hope that all those things will make it easier for you to master the material. The downside of that is that if you're not finding this material that difficult, you might end up getting really bored and impatient by these videos. Well, that's fine. That just means that maybe you'd be better off learning the material from some other source. But again, I'm intending these videos for people who are finding the material to be difficult, so I'm going to go quite slowly and repeat myself a lot and try to give a bunch of examples. Another point is that, again, because I'm thinking of people that are finding this material difficult and people who make a lot of mistakes, I'm going to be a little bit bossy in these videos. That is, I'm going to keep repeating over and over the exact way that I recommend that you do the problems. For example, I'm going to give you certain problem-solving techniques, and I'm going to keep reminding you over and over to use those techniques. Or I'm going to introduce some notation, and I'm going to try to keep reminding you over and over to actually use that exact notation. And again, I hope that won't come off as too annoying or bossy. But the point of that is that if you're finding this material difficult, it really is important to use the best possible problem-solving techniques and also to use the best possible notation. And for a beginning student, it's very hard to keep remembering what the techniques are and what the best notation is. So again, I'm going to keep reminding you or even hectoring you about that a little bit. And I hope that won't come off as too bossy.